Anyway, let's think, because Nikki, you brought up a really good point last lesson. The data which I gave you for homework to have a look at, those guesses if you like, these are just guesses. So how on earth can you use those guesses to understand what is happening at the population level, to understand how many jelly beans there are in this jar, okay? Well, one way of doing it is to use the idea of the wisdom of the crowds. Now, has anybody come across the wisdom of the crowds before? No. So, okay, the wisdom of the crowds, here's the idea. If you take lots of sensible guesses, then the more sensible guesses you take, that should tend towards the right answer, okay? Now, an example of where this is used, has anybody ever heard of the game show, TV game show, Who Wants to Be a Millionaire? Yeah, okay. So one of the things on there, so basically, for those of you that aren't aware, a question effectively gets asked. So for example, somebody might get asked a question which is, which of the following is an example of a discrete quantitative variable? And then they're giving 4 multiple choice answers, okay? So the 4 multiple choice answers may well be height, age, gender, or mood, okay? Now, by the way, which of these, A, B, C, or D, is an example of a discrete quantitative variable, okay? So hands up for A. Hands up for A. Hands up for B. Hands up for C. Hands up for D. Okay, okay. So it's a varied mix, okay? But let's suppose we had no idea. Well, what you can do is employ one of your lifelines, okay? So on this TV game show, you can employ one of your lifelines. And the lifeline is ask the audience, okay? Now, there's about 100 people sitting in the audience, okay? And effectively, they're asked to vote as well. And they say, okay, what do they think? Now, most of the time, the audience get it correct. And the reason being, because even if they don't know, they may have an inkling. They may have a guess. It's a sensible guess that they might have. But if you put all of these sensible guesses together, they will tend towards the right answer, okay? So in this case, let's suppose that 82% of the audience thought that B was the correct answer, okay? And it is the correct answer, okay? But my point is, the wisdom of the crowds is all about, if you take lots of sensible guesses, it should tend towards the right answer. So I'll skip over this, because this is literally what you've done, okay? You've literally taken the data set. So, let's have a look. These are some of the plots which I've produced. So I saw some of your plots and they're really, really good. But here are some of the plots which I produced from that same data, from that guessing, okay? The guesses which were in the comments. Does that make sense? Yeah, okay. So can you see from this is something called a dot plot. Along the x-axis, we have guesses, okay? So it ranges from 0 right the way up to 30,000. These are literally the guesses which occur in the comments section, okay? And then if you like, each dot represents a guess. Does that make sense? Okay. So where do the majority of the guesses lie? Where are the majority of guesses which people made? Yeah, between 0 and 3,000. Yeah, are you happy? But if you actually have a look at this, there's something interesting which happens. In fact, if you have a look at this screen over here, because I pointed out to you, can you see that some people were having guesses around 10,000? Now just bear that in mind and think maybe why that might be the case. But then there's also some really, really big guesses way over here. And in fact, I've just capped it at 30,000. I think some people were guessing like million and something stupid like that. But it didn't make sense to put the scale all the way out there just for 1 or 2 people, okay? In fact, what would we call that? So for example, you can see over here that there is a dot. In fact, there's a dot there, dot there, dot there. Does anybody know what we'd call those dots? The dots which don't really fit the pattern of the data. Does anybody know? Begins with an O. We'd call it an outlier. An outlier. Yeah, so let me write it down. We call it an outlier, okay? So an outlier is simply a value that doesn't fit. Sorry? Yeah, in English. Yeah. Outlier. Okay? Because it lies outside the pattern of the data. Is that okay? Yeah? Yeah. So maybe you knew it in your own language, didn't know how to translate it, that's fine. Okay? So if you have a value that doesn't fit the pattern of the data, and I think, Mahana, you noticed one, didn't you, or 1 or 2, and you decided to exclude them, you can make an argument to say, well, because it doesn't fit the pattern of the data, then I'm just going to exclude it. Okay? And we call that an outlier. So are you happy? This is one plot that you can have. It's called a dot plot, just simply because you are plotting dots, and each dot represents an individual guess, okay, an individual data point. Okay. Another example may be this, which is a histogram. Okay. Now, some people may know a histogram better as a bar chart. Okay. A bar chart is a type of histogram, but the reverse isn't true. Effectively, the height of the bar corresponds to the frequency of the guess. Okay. So you can see along the bottom there, I've still got the guess ranging from 0 to 30,000. In fact, it's a little bit further than 30,000. And then the height of each bar corresponds to the guess. Okay. So are you still happy that the majority of guesses occur between 0 and 3,000? Yeah? Why is this plot slightly better than the previous plot? So this is the previous plot, my dot plot here. Why is this plot, do you think, slightly better than that one? Okay, easier to see. What do you mean by that?
How many people choose what they choose.
Good. Okay, so it's a little bit clearer rather than just loads of dots platted everywhere. Okay. Is there any new information that gets revealed in the histogram that wasn't revealed in the dot plot? Okay, so there's the dot plot. There's the histogram. Is there any new information that you can get from this?
The curve.
The curve. Yeah, good. The curve. So what do you mean by the curve?
Well, usually when we look at data, when there is a graph, so we look at if there is any symmetrical or unsymmetrical distribution. So you
Perfect.
can see how not accurate.
No, I get what you mean, though. I get what you mean. The trouble with just plotting loads and loads of dots, okay? The trouble with just plotting loads and loads of dots is that everything is kind of jumbled up. But as soon as you have a histogram, you can start to see the shape of where the data is. So you can really easily see here, for example, that there's not many guesses between sort of way down here, right down the bottom, but there's more guesses kind of between here and here. But you notice that there's still that interesting spike at 10,000. So again, keep that in your mind. Why do you think that could be the case? This is what a statistician is supposed to do. They're supposed to look at the data and then think, that's interesting. Why does that happen? Okay. Anyway, some more plots which you could draw. Okay. So here is another plot. Effectively, you take a histogram and you just smooth it out. Okay, you just smooth it out. We call this a density plot. Call this a density plot. Okay. It's pretty much the same thing as a histogram. It's just smoothing it out a little bit. And again, it's just to kind of get the feel and the shape of the data a little bit more clearly. Okay. One final plot that I did was this, a box plot. Okay? Box plots are really useful. I love box plots. Okay? Effectively, we'll talk about box plots a little bit more, but effectively what a box plot does is it kind of shows you where the majority of the data is, and then everything else just gets treated as outliers. Okay? But we'll talk about that a little bit more. Okay? So here are our four graphs, or the four graphs that I produced, next to each other. Okay? Now, based on this data, do you think our guesses still hold? So our guess of the number of jelly beans in the jar is about 1,750-ish. Okay? Are you still happy that guess holds?
That's the median, though.
Okay.
This is also the mean.
Good. So we'll come on to that in just a second. Okay. So different types of averages that we can sort of get out of this. Okay. But are you happy that 1,747, we say in the majority of the data, lies down here? Lies in this region down here. Okay? Would you be happy that our guesses, which you came up with, still lie in this point down here? Okay? So let's have a look. Let's have a look at this. Okay? Yeah. Let's have a look at what Ahmed was saying. Okay? There's three types of ways of getting a guess from a set of data. Okay? So effectively, I've given you a load of data, and I've asked you to produce a single value that you think represents that data. Okay? Now we call that value an average. An average. Okay? So an average is essentially the best guess that you can come up with that describes this data. So literally answering the question, how many jelly beans are in the jar? You come up with an average. Okay? Now there's three types of averages. They all begin with M. Okay? You've got mean, you've got median, and then you've got mode. Okay? Does anybody know the difference between those three?